So for the very last part of this problem, we're going to go back to the beginning to figure out what is the force exerted on the 5 kilogram block by the 3 kilogram block. So we're actually going to solve for that interaction force between the two blocks. So if we look at the separate free body diagrams for a second, I'm actually interested in this force right here, FBA. So I could choose either of these free body diagrams to solve for that force since it's the same in magnitude for both objects. I'm going to choose the easier one to solve. I'm going to choose block B because it only has one force in the x direction. Ultimately, it does not matter, but I'm going to solve the one that's easier. Here's my coordinate system again, x and y directions. So using this block and going back to Newton's second law here, F net x equals the mass of block B times its acceleration. In this case, the only force acting in the x direction is the interaction force, and that's equal to the mass of block B times its acceleration. I know the acceleration now, and I know the mass of block B, it's 5. The acceleration is 0.875, rounded to two significant figures. So my interaction force comes out to be 4.375 newtons with two significant figures. So the way my question was worded was, go all the way back up, determine the force exerted on the 5 kilogram block by the 3 kilogram block. That force is going to be to the right because block A is pushing on block B towards the right. So I'm going to include that direction information in my final answer. Therefore, the force from block A pushing on block B is 4.4 newtons right.